In 1.4, we're only going to cover one objective. So let's just look at a couple of problems and then I'm going to add some examples from the textbook. But if you look at number 1, this says determine whether the statement is true or false. The number square root of 25 is irrational. Now right beside it we actually have the definition of irrational numbers. Irrational numbers have decimal representations that terminate or repeat. That was a true-false question, and that one was false because the set of irrational numbers is the set of numbers for which their decimal representations are neither terminating nor repeating. So irrational numbers, their decimals don't repeat, they don't terminate. So when we're asked if the square root of 25 is irrational, now we know that the square root of 25 is equal to 5. And 5's decimal representation, if I were to continue this out, 5.0, it stops. It terminates. So this would be a false statement. The square root of 25 is actually a rational number. And remember, rational numbers can be written as a fraction of integers. I could rewrite 25 as 5 over 1, so that's a rational number. Now if I had the number square root of 24, let's look and see if that would be rational or irrational. So if you pull up your calculator, and I want to show you on your calculator where you can find the square root key. So if you'll look at the button, the x squared button, the second function is the square root key. So I would type second, the x squared key, which gives me the square root, and then type in the number 24. Now I can use the arrow key. See how it's flashing? To get out from under that radical, I'm going to just push the right arrow key, which will take me out of it. Press enter. Now notice that it's given me still a radical form. Anytime you're in a form that maybe there's an additional form that an answer can be given, notice that there's a double arrow key above the enter sign, and if you'll click that, then notice that it gives me the decimal representation. I clicked it a couple of times, so let me do that again. If I type in the square root of 24, and if I press enter, there's the radical form, click the double arrow, and it gives me the decimal form. Now notice that this decimal doesn't terminate, it doesn't repeat, so this would be an example of an irrational number. So the square root of 24 is irrational. Okay. Now let me give you just a few more examples. If you'll turn in your textbook to the homework, look at the homework number 11. 11 has the square root of 173, and we're asked to round that in to the nearest tenth, to the nearest hundredth, and the nearest thousandth. Okay, so in the calculator, I would type in that square root of 173. Press enter. Notice it's just giving me a radical form, so I'm going to click the double arrow key, which gives me a decimal form. Now if I'm rounding it to the nearest tenth, let me grab that again. If I'm rounding it to the nearest tenth, I'm going to only need one decimal place, so I look to the right and I've got 13.15, which will round up to be 13.2. Okay. If we take it out to the nearest hundredths place, we need 2 decimal places. If I look to the right, I look at that 2, which is less than 5, which means that I'm going to stay at 13.15. And then if I round to the nearest thousandths place, I need 3 decimal places. But in looking at the 9, that makes me go up 1. So 13.153. One more thing I want you to see on the calculator is where the pi key is. So if I were to look at finding the square root of pi, which is number 15, the square root of pi, and you can find pi right here in the left-hand row. We've got pi, remember, is a number whose approximation is about 3.14. So the square root of pi, press enter, and if I round that to the nearest tenths place, that would be 1.8. We'll go a couple more just to finish this example out. The nearest hundredths place would be 1.77. And then the nearest thousandths place would be 1.772.